Good morning, good afternoon, and good evening. Welcome to model verification updates. So let us see a few minor updates for this version 22.1. So for today agenda, I have these four topics, intersection, then match function, comparison, and other details. Usually I start with this overview function. We have part comparison, which compares two models. Then we do have intersection check, which does the intersection check on our CAD data and finds the problem and reports in a PPT and Excel. The next one is spot weld check, which checks the spot weld data against the CAD data and finds out all the issues related to the spot welds. The next one is connection check. It is a misalignment between a bolt nut and bolt hole, and it reports the results in the power quant. The next one is free part check for finding unconnected parts, even on the CAD data itself. The last one is spot weld comparison for comparing 1D elements between two models. So these are the six suite modules available in MBD function. As you know, from 22.0 onwards, the MBD is working on a stack units, and all our customers started using our latest versions. So with that, I will go on the updates. The first one is intersection check. We added a symmetry filter. So this is to avoid duplicate intersection reported on the symmetry locations. Imagine you have a model, as I show in the right down side, LH and RH side. If the intersection is happening at the both side, then we used to write two reports for LH and RH. So now with this new option symmetry check on in the configuration file, this can be reduced to one. Usually in a full vehicle symmetry models, the left-hand side model is usually reflected on the RH side model, and then for meshing or verification, we use those models and the symmetry locations are reported as it is, even for comparison and verification. So now we try to filter those reports so that user can reduce 30% of the reduction in a full car model. On the right-hand side graph, you see before and after for a vehicle, we used to write 568 reports for the same vehicle. Now with this modification, we are able to reduce to 385 reports. And while filtering the reports, in the report side, we are also adding that filter is applied, and this is happening at both side LH and RH side, so that the designer can understand that looking at the report saying that, okay, this is happening at the both side, but the report is generated only on the one side. Okay? So we have this kind of flag. In addition to that, in the configuration file, as a default, I turned off this option. For tolerance, I kept 0. If the tolerance is 0, I do the normal intersection check with having both the reports. But if user wanted to filter this, they can come to this configuration, and the tolerance side they can set 2 millimeters. So this 2 millimeters is nothing but finding the intersection location, the mismatch area across the plane, and it is using this 2 millimeters as search tolerance. So if LH and RH, the location of intersection is found within 2 millimeter tolerance, then the filter will be applied. If it is 0, then we will not apply any filter. Similarly, we have a overlap percentage in the same configuration file. It's a ratio of matching points between total number of intersection points. So with these two parameters, we are able to control this filters. Of course, I've given this option to users so that they can set this tolerance ratio as well as the symmetry plane. So with this, so most of our customers are running like 10,000, 12,000 parts in one shot and filtering out this kind of unnecessary reports. So by doing so, what happened in the past, we used to have this many reports generated for a body in white. Now with the same filter function, we are able to reduce this for a body in white. So now for only with this RH and LH report filter, we are able to reduce this number of slides. Now we are working with few more customers to see how AI can implement it and further reduce the slides. What are the area we can still reduce? Known issues, okay, and implementing mid-mesh, implementing offset, and implementing AI technology. All those things together, we can further down reduce this number of slides. So that we are working on and have projected that for the next release. So by doing this kind of a filters, what's happening? The duplicate reports are definitely reduced. the performance has increased. The number of reports, like if you are able to save under report, that much time can be able to reduce. And people who are spending time in validating the reports, good reports and bad reports, they're segregating, and for segregating, they're spending time. So people are working at different supply company, and they're trying to do this validation. Most of the day, they focus only on this validation and grouping of the reports. So that is also reduced. Next, the report communication. So what happened? They will try to group all the required reports, and they put it in FTP signs. And those reports are like 200, 300, 400. Okay, the valid reports. So it requires space, it requires memory, and it requires upload time. All these things are now reduced. In addition, the designer gets the report and they have to validate the report and to give the feedback to the CET. So that is also reduced. So all these things are happening. So in the future, we will still improve this to get down this to the very minimal number. So the next function is match function. As you know, Shape AI code works behind the match function. Most of the supply companies have a data and they send this to their customer. While sending their data to the customer, they try to put all the data in one part and send it. So single part will have multiple instances of parts, multiple solids inside a part. Okay. And if you try to run this as it is, it will affect performance and so many other problems. Okay. So now we need to separate those single part to multiple part based on number of solid inside the part, and based on number of parts, or based on number of components, or based on number of solids inside a part. All these things need to be shattered, and for each of those solids we need to create a part. So this will increase the performance for verification and comparison, as well as meshing and connectors and so on. So because each part management is very nice and it's very detailed, so that we can read those metadata and convert them to the connectors and so on. So it's really helpful. So some of the examples are connections like bolts, nuts, clips, and so on. So spot welds, bracket, harness, and clips. All this data sometimes comes from supplier, and they are single data, monolithic files. So we have very difficulty in assembly stage. So this match function, now we have implemented this part shattering inside the function, so that it recognizes the bolts, nut, washer, pins, and so on. So which I showed it in the arrow mark here. So those will be separated, and you will get a separate part for that, and which will inherit the parent part's attributes information like position information, part name, part ID, and other metadata. Excuse me. So the right side is a interface for running the match function. You go to the part comparison browser, select part and match, bring this window, and you select the part assembly and run it. This will be automatically done inside, and you will have more number of parts when compared to the original VDM XML. Then you are good to go for verification, comparison, or batch meshing through part browser. So it's all inbuilt. You don't have to turn on any options. It's all automatically done. So for some of our customer models, when we are trying to run 8,000 parts on this part match, it creates like 300, 400 extra solids parts, which is coming from the solids, which are valid, which are connections, and which are in single component, which gets segregated and parts are created. So it's all completed automated, and it's all batch processing. It does all the restarting recovery function if some of the parts are not read properly or crashes and so on. So it's just one function, everything is explained. So the next one is comparison. Surface deviation comparison, which we implemented in this release. So this will compare CAD to CAD and calculate the match percentage and mismatch area, even for the minor tolerance like 0.01, 0.02 millimeter, very minor. Usually 0.01, 0.02 millimeter are used only by designers, not from the CA team. CA team usually uses 1 millimeter, 2 millimeter, 5 millimeter. Okay. So there were few customers wanted to run CAD to CAD comparison, but they wanted to reduce the time. For example, there was a customer who was running 28,000 parts versus 18,000 parts. So the traditional CAD to CAD comparison is shown on the left hand side, called default comparison, which takes the model and perform the comparison based on the surface level. So we try to compare surface, we calculate the match percent based on the surface. There is no feature involved, we cannot recognize features, it's all surface based. So for this particular part, you can see 95% matching, though only two holes are mismatched. So this was the issue because we wanted to compare feature level, even one line, one hole one fillet is mismatching, we want to identify and calculate the percentage. So that was not possible. So to overcome this, in the past version 1920 onwards, we added this CAD to AFE approach. Based on supplier companies, somehow they wanted this CAD to AFE approach, which discretizes this surface data into small facets, then perform comparison. So the discretization method is happening at the batch mode, but it still takes time. Each part it has to take and it creates facets. So the time taken for facet creation is more. Apart from that, you cannot use minor tolerance like 0.01 millimeter to find the mismatches. So the maximum we can go up to is 0.3 millimeter. So if you want to still reduce the tolerance to 0.1 or 0.05, you need to reduce the facet size to very fine. If you decrease the facet size to very fine, it takes too much of memory and CPU, and time taken is too much. The performance goes very down. So this kind of limitation. So accuracy is the problem, performance is the problem. Okay, but somehow the match percentage is calculated very nicely because we have a discretized facets there. So we need a result, something like CAD to FE approach, but we need a performance similar to default. So now we develop this surface deviation method, particularly for this use case, a huge model, just like a designer we wanted to run, just like CAD software we wanted to run and identify the mismatch. So the surface deviation method, it combines both of this technology and give you the very accurate result, and the tolerance can be even, we have tried 0.01, we have not tried lesser than that, but that's what the designer requirement. So now we are trying 0.01 millimeter. For 0.01 millimeter, we are able to get a very promising results, and this customer have confirmed this to us. And the performance, everything is faster than the default, even 3 times faster than the default functions. So some of the logic behind this. So the left-hand side image shows two-part overlap, and the mismatch area is shown in the dark blue color, which is circled in red. And for this component, this pair of component, the result is 86%. Okay? So when we try to compare, we take model 1 and model 2. We take some sample points. I won't tell you how the sample points are created, but we taking time sample points from model 1 and project this to the second model for, for the nearest pair of surface, and we check the distance between the original to the projected. Okay? And if the distance is less than tolerance, we conclude that that is matching. Okay? So with this tolerance on the right hand side, you can see for 0.01 tolerance, the projected, the start point, end point, and it is connected with the 1D element. So this projected location looks like this. So if it is more than 0.01 millimeter, we conclude this all areas are mismatching. But in the default comparison, what it used to happen, all the surface was showing as a mismatch, but with the new option now, it shows only this mismatched locations. So that is the advantage. So we are taking directly the points, not creating the facets and perform the comparison. It's only the computation. Okay, so the performance is much better. Okay, and currently we have enabled this function in default comparison. So you don't have to turn any option. Okay, as a default with 22.1, this function gets activated and you should be able to see the performance. In the future, we will also extend this for Q comparison. I will show one demo how the default function of comparison should be executed using the current version. So go to assembly, click on comparison. The comparison browser opens on the left hand side. Right click, go to configuration. It's always recommended to set the configuration to default so that the old configuration gets migrated. Then go to right click, bring the check function so the comparison window opens. So this is the new version, new GUI for the comparison. I have IGS files to compare here, both the side. These few changes are there. So I'm trying to copy the path of this IGS file and pasting it in the new window. We need to select only the two models, model 1 and model 2. For now, it is file based. Whatever location you selected, it takes all the IGS file from there and create a BOM, especially for the base and variant. Then with this tolerance, it's going to compare. So for now, I'm trying to run 1 millimeter, and you have a nice tooltips. After running, you can see reports like this. So it shows the mismatch is 99%. Okay, so this is how you can run and get the reports. Okay. One more results, there is another part which is 45% match. And if you right click on the Excel report, it opens this report like this, and you can see the results in 3D. So this is the normal comparison. Now with the normal settings, you should be able to run this surface deviation comparison. Once you compare and see this results in PPT, you can come to browser, you can turn on and off the, the model 1 and model 2 to see the results clearly. Okay, so the workflow, the process, the time taken is not changed at all. In fact, the time taken has improved a lot, but the workflow is exactly same as the previous version. After checking the report, now you can also select the same part in the browser and right click review. You can see the results in the graphic. So this is the normal way of running the comparison. Now I will show you what is the difference, how we can get the beneficiation of this deviation comparison. Now if I run the similar model, little bit long tubular model using 21.2, what will be the result and what will be the match percent? I'll show with this small example. Okay, so for this model, I'm trying to use NX part. Okay, so I have a NX part and a simple part, but it's a long tubular cross section, which has 2 or 3 poles mismatching. Now in this situation, how this surface deviation gets benefit. So this video will show us very clearly. So I selected all the inputs, and the old GUI looks like this. You have a left hand side, right hand side options. You have top, down. So it's always really confusion to select which option should be ignored. Okay. But in the new GUI, it's all vertical based so that you can select and choose option one by one from top to bottom. So after selecting all the inputs from the GUI, you can go to configuration and set to default so that all the information, all the settings will be done for 21.2. Now clicking on the run, it imports the NX1 and NX2 part and creates the path structure on the left hand side. Then it performs the comparison. Very two-part, simple part, but it's a long tubular. You won't see much performance gain for single part because we have a lot of overhead time at the back end. We try to do monitor the process. We try to see if the process is running without memory or without time taking and so on. So it takes a lot of overhead time, but you will see a lot of performance gain in the bigger model. So for this model, it shows 36% match, only 36%. Okay, 64% is mismatching. Now, if you right click and review the results, it's a long tubular section. The right walls are showing as a mismatch. But actually speaking, the right wall, there are only 2 or 3 holes mismatching in this area. We can see on the left hand side, the holes are mismatched. So because of this holes mismatching, the hole is inside the surface, so the entire surface gets mismatched. That's what in the older version, it's a surface level comparison. So everything is on surface. If one hole on a surface is mismatching, we'll say the whole entire surface is mismatching. So that was a limitation. So due to that reason, the top and bottom surface are matching, but the side walls are mismatching. So that's why it is showing 36% mismatch. To overcome this, now we have the deviation comparison. So I have another recording for 22.1, which uses the deviation comparison for the similar part. So in this case, I'm trying to use a new version, new GUI for selecting this JT. And the GUI is also very compact. Similar way, I'm trying to copy the path. And confirm the path is correct. Similarly for the variant model. So this time let's try with only check option, not going for report. So we'll try with 1 core and 1 mm tolerance and run it. So the GUI also looks very complex. You just have to go through top to bottom. So you'll have no confusion at all. This GUI also comes with a lot of tooltips. If you keep your cursor on the tolerance, it will tell you what is the advantage of bigger tolerance and smaller tolerance. And the progress message showing on the left down side. So 98% is completed. Soon it should be completed. Now you can see the match percentage filled with 99%. So the same model, same setting, same configuration with the new version shows 99%. So let us review the results. Now in this result, we can see the color is blue. The mismatch is calculated as 99%. So only for the whole area, that is feature level, the mismatch is calculated. But while showing the results, we have no other way showing the surface. Okay, though it's a hole, but the hole is inside the surface, so the surface is shown as a mismatch. That we are trying to work on a little bit. We need to see how the feature level can be displayed as a mismatch in the next version. So now we are showing surface as a mismatch, but calculation happens on the feature level. So that's why you can see 99%. So this kind of models are widely used in bus model, truck models, and heavy industries, and some of the components in automotive industries, like a steering wheel, rocker arm, and so on, so like big circular tube sections and the circular square section and so on. So most of the areas was having this kind of troubles. So now it's all going to be sorted out. And also the performance is gained, not only for the similar structure, even for small or bigger, now the same function works fine with a higher performance and very accurate results. So as I said, the customers are trying with 0.01 millimeter tolerance for more than 20-30,000 parts. And with the traditional normal comparison, we were not able to, I mean, we are able to solve, but it's not able to solve within their expected time. So now this new function is going to work fine. We're going to put it in the server and try it out. So it's much better. So let's give it a try. So the next one is detailed comparison. So, so far MVD was focusing on shape-based comparison, that is topological or geometrical comparison. So we were not able to compare materials and properties and so on. So we were comparing only the material string names and thickness values on a component level. We were not able to compare any of the attributes of the materials and thickness sounds. So now for the first time now we added this model comparison where it can do a primary and secondary model comparison, and it can compare the card level, okay, each and every card and comparison. So we can call this as a detailed comparison, a parameter comparison, and model comparison. It's all about your the parameters inside your each entity, so that can be compared. So I'll show a little more details. So the first window is for you to select the model. As I said, there is a primary model and secondary model. And the left hand side I've written down, you see, primary model is seen in the graphics and it will be stored in a first database. Then we select the secondary model. First, you have to import the primary model in the graphic, then bring up this window, then select your secondary model. So internally, we read the secondary model and store it in database too. And the secondary model is only for read-only option, and it does the FE to FE comparison at the backend. Okay, and user can edit the mismatch information of the primary model, which will be always shown in the graphics. You can edit. After editing, after closing this window, you can also export this as a solver deck after editing. Okay. On the right hand side, few details. Primary model is a new model. Secondary model could be your reference model. Okay, so you wanted to keep a reference and you wanted to compare always with your reference. Then we have an enable hierarchy where after running this results, if you want to group your results in a hierarchical manner or a flat list. So this enable hierarchy option allows you to do that. The next is entity type. Currently, we can select few entities like materials, property, context, or you can do all options so that all the entities available in the model can be compared. Of course, many entities takes a little bit time, and less entity will be less time. Of course. Then comparison rule. Currently, for this version, we are enabling ID-based comparison and string name-based comparison. Okay. So the comparison means if you have a component ID 1 and the right hand side model has a component ID 1, if we enable this ID, then if it is 1 here and 1 there, then we'll try to put this 1 and 1, we'll perform comparison. So similarly for the name. The next one is advanced option. We have ignore include. If we compare the entities and if you turn on this flag, then we will not consider if the include ID is changed or not for that particular entity. If you're working on the bigger include files, master and include files, then you can decide to turn on and off this function. then tolerance ratio to give a allowable ratio or deviation from your floating values. So these are the major parameters available in this detailed comparison. So once you execute this, the model will run. Finally, it will give you this kind of a split window. In the split window, on the left-hand side window is for the primary model. Right-hand side window is for the secondary model. And it will show the mismatch in red color and matching ones are in black color. Okay. So the top window is for this showing left-hand side, and the bottom is for seeing the parameters. Entity editor kind of a window is available at the bottom side for both primary and the secondary. On the right hand side, I have given few details like checkboxes are there. There is a live sync where it can do a dynamic update. If you change any parameter, it will dynamically update and show the mismatch information directly on the split window. No need to run again the checking function. Okay. If you turn off the live sync, if you make any modification, you need to rerun the check from this window one more time. So that is the live sync advantage. The show warning is available, then different parameters. When the parameter is completely mismatching, then we put this into different category. If the IDs are mismatching, that means when you're trying to compare two entities and the reference entities IDs are mismatching, but the parameters are matching, parameters are mismatching, then we put as not equivalent. Okay, so IDs are mismatching, but the parameters might be. So we don't care about IDs sometimes. If the materials are perfectly matching, all these contents are matching, even if the IDs are different, we don't worry for the solver point of view, right? So that's why, so we put this not equivalent and equivalent. So equivalent is opposite to not equivalent. Then we have same. So all the parameters inside the card is perfectly matching. We put in the same category. So basically same category, different category, and equivalent, non-equivalent category. The next one is show only differences. So if the parameters are somehow different, it will show in red color. If you select that parameter at the bottom screen, if you select that show only different, it will exactly tell you which parameter of that card is mismatched. Okay, for example, thickness is mismatched. As I show on the left down side, if you want to see only thickness or only the mismatch area, it will show like this. No need to see all the entity editor at once. So this is very useful option. So these are the basic options available in this window for this release. In the future, we will try to improve more. I will also give you one demo on how to run this. I have two videos. One is short video and long video. For customer, you can show this short video, and for internal purpose, I have recorded this long video. Okay. How to open? So normal 2020.2.1, you can launch. Then you set your solver profile. So we support all the major solvers. Radios, OptiStruct, Amcrash, Dyna, Nastran, Abacus, and so on. So solver. You just have to select the solver profile, then import the primary model, then select that window and select the secondary model. So that's the process. So first let's import a solver deck. So for this demo, I'm trying to use an LS Dyna model, which has many parameters, many entities. So this is a normal way of importing model in HyperWorks. So once the model is imported, so then we go and launch a comparison browser. So this many entities are available in this model. So let's try to compare all of these entities. So let's go to assembly, go to comparison ribbon. It will launch the comparison browser on the left hand side. Right click on the white space, go to tools and click on this detailed comparison. Okay. So this will bring the same window. Now the primary model is already loaded in the graphics, okay, and it is stored in database 1. Now let us select the secondary model. So I've selected the file. Now I'm showing few of the options. So component hierarchy, specify hierarchy, and none. Three options are there. When you select specific hierarchy, it will allow you to select the entities that you're interested to compare. So using custom, you can select some of the entities is available in this model. Okay. But if you don't want to do that, you can go to component hierarchy. So that component base hierarchy will be displayed in the results. If you put none with a flat list, it will show the results in the graphics. Now for entity type, I can select custom, so I can choose only this entity I want to select, compare, or I can select all of the entities available in this model browser. The third one is rule, ID based comparison or name based comparison. So for now, let's select the ID. The next one is ignore include file. If the include currently in this model don't have include, but if you have include, you can turn it on. Off. The tolerance, I'll keep it as it is. Then click on compare. So what it happens when you click on compare, the primary model is already loaded, but we try to load the secondary model as well in a secondary database. Okay, so we see the secondary model like this. We extract all the information from the secondary model and store it in a database. Then we'll switch it to the primary model. Then we'll perform the comparison. So most of the time taken is for loading model 1 and loading model 2 and getting the information on database. Then the performance, the comparison goes very fast. For this model, the comparison takes only 20 seconds. So we're also constantly testing on bigger models. Okay. So in this window, you saw same and different. Okay. So this will show both matching and unmatching. The matching entities are shown in red color, unmatchings are in black color. So now if we click on same, different, then it will show that the mismatched entities. So it groups based on the mismatched entities. Now for component, you have only one component and it is shown in this bottom view entity editor. It shows all of the parameter or card details of that component in this entity editor. I know it's difficult to scroll down and find which is the mismatching, but I'll show you how we can do this using the show only differences. For now, you can see this card editor is completely shown. Similarly for the property as well, so that you can scroll down and check it out. Now, if you click on the show only difference, select the component, it shows the number of elements between the primary and second is different. Then the property, the thickness by mistake user has input 1586 instead of 1.5. And material value, Poisson ratio value is different. So you can clearly see the exact mismatch area or mismatch item in this show only differences. Okay. So after verifying the difference, of course, you can take a screenshot and communicate to your counterpart and say, this is a problem, what should I do? So they will say, okay, modify or not modify. If you want to modify, you can directly select this primary attribute and click on modify. It will give you this warning. Then it will correct. It will remove that modified items from the different category. Okay. Similarly, we can do this for one more thickness value. So now it is shown in the different, it gives a warning. Then if you click on yes, then for the same property group, there were two parameters mismatched. The first one we corrected, then it brings up the second one. So you say, oh, this is also mismatching. Okay. So you can keep correcting until the whole property is completed. So this way it will give you one by one in the same parameter. So now you corrected two things and two of them are moved from different category to the same category. That means all are perfectly matching. And there are some right click options to show this list into group or flat structure. So this is the basic structure, okay, for different and same category. So now let's try. There are some chances where you have some parameter, but you thought this was matching and it's all working fine, but you wanted to correct some of the value or change some of the value. Okay, so how to do this? For example, for this property, first property for ID 5, I'm going to change the thickness from 1 to 2 millimeter, and my live sync is on. That means dynamic update is on. The moment I click OK, the property gets changed and it is moved from different same to different. So it's gone from this group. Okay. Similarly, we'll do it for one more property, which is for 6, and I can add it as 2 and click OK. Then it gives this warning. And if you click OK, then it moves that category to the different category. Now, if you click on the different category, it shows those two modified parameters or two modified entities under property. Okay. Now, if you click on show only difference, you can see that modified values like this. So this is the meaning of the live sync. So whatever you do, it's lively get updated and dynamically it's get updated. Okay. So now let's see how we can use this without live sync. Okay. So now I'm trying to change the third entity, similarly, uh, 3 millimeter thickness, and clicking OK. Now instead of warning, it says the result is out of sync. That means the database between left and right is out of sync. So what do we do? Now it allows you to rerun, so that it can rerun the comparison between primary and secondary using this modified information and give you the results. So this way, you can use live sync to dynamically update, or you can make all the modification at the end. You can rerun it to get the comparison. So both options are available, and you can try. The live sync is always time saving, so it updates there itself and gives you the mismatch information. Okay. So this way you can confirm the mismatch information. So for this release, yeah, for simple model, complex model, medium complex model, three categories. So I recommend you to try for the simple and the medium complex model for this comparison. We are constantly testing even complex model, which consists of 5 million and 3 million elements with all the entities from different solver, and trying to tune the performance. So down the line, we will keep improving this. For now, try to test this and promote it to our customers who are using MVD for model comparison, using shape comparison. They have many people have requested me for this attribute comparison or parameter comparison. Finally, we have it. Show them and try to play with them and get us feedbacks. Okay. So after all the modifications, now if you want to save your model, you can always go to File, Export, and export your solver deck and close this window. So this option allows you to do that. So the few other updates what we had for today is quick comparison. The quick comparison CAD thickness calculation from the CAD is implemented. Earlier it was not there. Similar to normal comparison, now we can extract thickness from the CAD and put that in the browser and also in the Excel report, so that if you're trying to do CAD to CAD comparison, you can see the thickness from LH and RS, or if you do CAD to FE thickness, FE comparison, you can see the thickness from the calculator from the CAD and compare the thickness from the FE, okay, which is coming from the property. So now it allows you to do that. Then we have few bug fixes. The CAD to CAD comparison report side, thumbnail image was not showing as shading mode was showing wireframe. That is also fixed. Then when we are doing CAD to FE comparison, if there is a partial mismatch, consider there are 80 to 90% mismatching, we can automatically run batch measure at the back end for the unmatched parts. And it was not working in batch mode. So now we fixed that problem as well. Then multi-variance, when you're trying to do CAD to FE comparison, we can do a multiple variant comparison. Up to 12 variants you can compare at once against your CAD data and find which is the best match. So that had a bug, and that was also fixed. On the intersection side, now we have tuned to handle a huge model up to 15,000 model, 15,000 parts we have tested and confirmed it's all working. 15 and 18,000 also we have tried using GT assembly file, IG files, and NX file we have tried and make sure that it's all running at the till the end and till the report generation. So usually it is to stop for the memory and so on. So now we optimize such a way that it can use only few memories internally. We make a block and perform the intersection so that it can run till the end. So that kind of development was happened in the past release. Finally, the intersection check, when we are trying to do a solid versus surface intersection for a long tubular section, it was missing some of the valid intersections, so that also improved. So with this, I would like to conclude my presentation. Thank you so much, and give it a try for this release.